Okay guys, in this video we're going to have a look at how ionic compounds are formed, particularly how ionic compounds are formed from their constituent elements, that is, the elements that make them up. So ionic compounds, we know, are made up of metals and non-metals coming together. There's a couple of things that we should note. Metals, we know, form cations pretty much exclusively, whereas non-metals, they form anions. So the cations are the positively charged ions and the anions are the negatively charged ions. So with these metals and non-metals coming together, there is what we call the transfer of electrons. And the transfer of electrons occurs from the metal to the non-metal. Transfer of electrons. So it might be more than one electron, or it might just be one electron. Okay, so let's have a look at this first example. Now lithium we know to be a metal. If we look at our periodic table, we find lithium is in group 1. As a group 1 element, lithium should have one electron in its outer shell. So if we draw an electron dot diagram, so electron dot diagrams pretty much only show the valence electrons. If we draw an electron dot diagram for lithium, the metal, lithium will have one electron in its outermost shell. Fluorine, on the other hand, fluorine, if we look at the periodic table, fluorine over here, fluorine is a non-metal. It's in group 17. Now, elements in group 17 have 7 electrons in their outermost shell. So if we draw a fluorine, and I'm going to draw fluorine's electrons as crosses, fluorine will have 7 electrons in its outermost shell. Now, if we look at the electron shell structure for lithium, so I'm going to draw all the shells, lithium will have 2 electrons in its first shell and 1 electron in its second shell. Now, if you imagine that lithium were to lose this 1 electron in its outermost shell, it will have a full outer shell, essentially. So in losing that 1 electron, it will become positively charged. And it looks like a noble gas. Noble gases, we know, are stable. Are stable. So noble gas here, like helium. Helium is element number 2 on the periodic table. Atomic number 2 means there's 2 electrons in the outermost shell. Well, it's only shell. And that's a very stable element. So lithium has managed to look like helium. Look like helium here. And this is stable. A stable lithium atom. So if lithium could somehow lose this 1 electron over here, it's going to be very happy. Fluorine, on the other hand, really would like to gain 1 more electron in order to have a full outer shell, an octet, that is 8 electrons. So, you wouldn't be surprised to know that these 2 elements are made for each other. Lithium would love to just give away its electron to fluorine, and it does. Now just recall at the beginning that I said ionic compounds are formed from the transfer of electrons. So you can see the transfer of electrons from metals to non-metals. Here lithium, the metal, is transferring its electron to fluorine, the non-metal. And the result is a lithium ion and a fluoride anion, where fluoride has gained its 1 electron from lithium. So fluoride is an anion. I'll circle the charges so they're a bit clearer. And if you remember that opposite charges attract, this is the basis of the strength of the ionic bond. So this positive charge here is strongly attracted to this negative charge here, and it holds these two elements together. So this here is our ionic bond, which is very strong. Okay, now sodium and chlorine, sorry, I wrote chloride here. It's worth noting that the element, before it becomes an ion, doesn't take on the IEDE suffix. Fluorine over here, when it becomes an ion, this is a fluoride ion. Okay, now I want you guys to have a go with sodium and chlorine. Just pause the video if you want some time to do this, but I'll work through it very quickly. So sodium, same as in group 1, so it has 1 electron in its outer shell. Chlorine, oops, I'll draw crosses. Chlorine has 7 electrons in its outermost shell. Sodium will transfer 1 electron, which gives us a sodium ion and a chlorine anion. So chlorine is negatively charged, and the two of them, the opposite charges attract. Okay, so let's have a go with magnesium and oxygen. Now magnesium, if we look on the periodic table for Mg, magnesium is in group 2. As a group 2 element, it will have 2 electrons in its outermost shell. So I'm going to draw those. 1, 2. Oxygen is in group 16, just over here. Now group 16 elements have 6 electrons in their outermost shell. Oxygen, 1, 2, 3, 4, 5, 6. Now, for magnesium to obtain a full outer shell, the easiest and most efficient way would be for it to lose those 2 outer shell electrons. So it would transfer them away to a non-metal. Oxygen is one such non-metal. Oxygen would love to be able to gain 2 electrons to complete its outer shell and become an octet. And so magnesium and oxygen are really good partners, because magnesium will offer both its electrons to oxygen, and in doing so form a magnesium 2+ ion, 2+ cation, and oxygen forms its oxygen 2- anion. And as I mentioned previously, these opposite charges, they attract each other very strongly, and that's a very strong bond. In fact, this bond between magnesium and oxygen is much stronger than the bonds between lithium and fluoride and sodium and chloride. So if you have a look at sodium and chloride and lithium and fluoride, these are single charges, single positive charge with a single negative charge for lithium and fluoride and sodium and chloride. And these single charges aren't as strong as the double charges that we see with magnesium and oxygen. So we see some differences in the properties of these compounds, which we'll talk about in another video. Okay, so calcium sulfur is similar to magnesium and oxygen, so you can pause this video to work through that one if you like. I'll work through it very quickly. So calcium and sulfur. Calcium will transfer its 2 electrons to sulfur, which gives us a calcium 2 plus cation and a sulfur 2 minus anion. Okay, so that's calcium sulfide right there. Okay, now calcium and chlorine are a bit different to the others that we've done so far, and I'll show you why. So again, calcium, we know group 2 has 2 electrons in its outermost shell. Chlorine is as we saw before, is a group 17 element, so it has 7 electrons in its outermost shell. Now chlorine can only receive 1 electron from another element. Calcium can give 2. Now calcium can't give both of its electrons to a single chlorine atom. It can only give 1 to a single chlorine atom. And if it transfers 1 electron, it would be left with 1 still. But that can easily be fixed by having another chlorine atom available to receive the other electron. And what do we get? Well, calcium 2 plus and its 2 plus charge is matched by 2 separate singly charged anions. So we've got chlorine here, and we've also got chlorine here. And if you know your ionic compound chemical formulae, if you were to make a compound of calcium and chlorine, or calcium chloride, it would be CaCl2. And that matches this ionic compound drawing that we've made just here. We have 1 calcium and 2 chlorides. And in the chemical formula we see 1 calcium and 2 chlorides, okay? Alright, so sodium and oxygen is similar to calcium and chlorine. You can pause this video. I'll work through it quickly. Okay, so sodium, 1 electron is out of shell. Oxygen has 6 electrons. Now sodium, each 1 sodium atom can only transfer 1 electron, which means we need another one. This transfers its electron, and we get a sodium ion, 2 sodium ions, and an oxygen anion. And the 2 minus charge from the oxygen here is balanced out by the 2 positive charges from the separate sodium ions. And the chemical formula for sodium oxide is Na2O. Okay, now aluminium and chlorine. This is the last one. I'll work quickly through this one. It follows a lot of the principles that we've seen so far in this video. Aluminium, group 13, means it has 3 electrons in its outermost shell. Chlorine, you know, to have 7 electrons in its outermost shell, and you'll need 3 chlorines to be able to receive the 3 electrons from aluminium. So 3 chlorine atoms, 1 electron each. And the result, an aluminium cation with a 3 plus charge. And then we've got 3 chloride anions. 3 chloride anions. Each an anion because it has received an electron each from that aluminium atom. And so it's no wonder that with those 3 chlorines into that single aluminium ion, that we have AlCl3 as the chemical formula for aluminium trichloride.